Evening, everyone. Just a little introduction. My name is Steve Bauer. I work for Bloomberg. I run our search infrastructure team. Normally, people from Lucidworks are here opening up and everything, but they have some sort of company retreat today and asked us to run the show tonight. So without much more ado, I'll turn you over to Dan Collins, who is on our news search team, and he's going to talk about real-time news and alerting. So.
Okay. Thank you. Everyone hear me okay? Cool. Right, let's crack on. Okay, so the basic kind of agenda for this. So this is our talk about our real-time news search and alerting engine. This is going to focus mostly on the alerting side of things. There's been a talk already at Solar Revolution about the search side. So that's why we're kind of focused more on alerting here. General kind of order of how we're going to do this. So the usual kind of things, the general introduction, run through the search ecosystem. Basically, that's just kind of going to outline the problem that we face. One through our solution or solutions, the few attempts we've had at working through this problem. We'll run through some stuff about Luwak, which you may or may not be familiar with, and Baleen, which is a component that we're working on. And then some interesting issues and kind of use cases that we kind of found along the way. Just quick show of hands. Has anyone been to Solar Revolution? Ooh, a whole 3 people. I don't get paid by Lucidworks, but I would advocate going. It is a very good conference. There's quite a good mix of talks and an interesting mix of people there. Right. So Bloomberg. Bloomberg, I guess, kind of has this image as being just that kind of finance company or a TV station, depending on how you look at it. But we're really a technology company. We just happen to focus mostly in the financial data area. But our strength basically is just the data that we maintain. Yes, that mostly has its kind of financial data. But we're branching out into all kinds of areas. We're branching out into law, into government. So we have quite an eclectic mix. In terms of news, we are both a creator of news and a consumer of news. So we have reporters all around the world, in offices pretty much in every major city. But we also consume news. So we take both our content, we take content from the major news, the other major sort of news generators, sort of New York Times, Wall Street Journal, the BBC, and we also web scrape. So I think we have probably about 125,000 sources we pull data from, and we send that out to our clients. In terms of the open source contribution, that's been kind of generally increasing over the last couple of years. It's something that I think a lot of corporations are deciding that they need to be sort of part of. They can't just kind of sit behind closed doors anymore. We've got 3 Solar committers within the company. There are 2 in our team in London and 1 here in New York. And in terms of sort of contributions, I know New York has contributed an analytics package. We've kind of mostly been doing bug fixes around kind of the scalability stuff that we've had to deal with in the search space, but there are a few sort of things coming up that we're hoping to open source. In terms of myself, excuse me. So I've been with Bloomberg 4.5 years, coming up 5 years this summer. I've worked generally on the search and indexing infrastructure. Been working with Solar for about 3 years now. We started back end of 2012. And for the last 18 months, I guess, I've been working on this alerting migration. This is one of these great slides that we managed to get put together, which just kind of, I know there's kind of lots and lots of numbers on there, but it just kind of indicates some of the stuff that we have to kind of deal with. Things to kind of probably take note of. Alerts in 100 milliseconds, that will come back. In terms of the actual alerts themselves, we've got 1.5 million saved searches. We've also got 8 million searches that our users run every day. So again, that number may come back later. In terms of where we fit within the whole kind of ecosystem, so the blue box is the stuff that our team handle, or at least that's the purpose of this talk. So we cover both search and alerting, but for the purposes of this talk, I'm really just going to kind of concentrate on the alerting side of things. Okay, so just to kind of outline the complexity. So in terms of news data, you might think that's kind of fairly straightforward. We don't probably have the largest scale in terms of documents coming in. It's still kind of a good couple hundred a second, but no, it's not Twitter volume. But then Twitter also do have the advantage that all their messages are exactly the same size. News stories obviously can vary wildly. They can be anything from a headline that's just 80 characters long, or it could be a research document that's data extracted from a PDF and it's 10 meg in size. So there's a kind of completely wide variety of data that we have. In terms of the data itself, it's your usual mix of kind of unstructured and structured. Unstructured is obviously the stuff that we generally get from the external sources. Structured data tends to be data that we've basically augmented on top. So we have an entire classification system, excuse me, which will basically do kind of entity extraction to look at sort of people, companies, topics, and this kind of thing that may be associated with a particular story. They'll augment that data, and then all that data gets stored in our Solr index. This is an attempt to show you kind of our query syntax. This is a relatively simple example, oddly enough. They do get substantially longer than this. But at the moment, this is just kind of trying to show you the complexity. So we've got all the usual things. We've got a mix of keyword queries and kind of field topic-based queries. We've got Boolean operators sort of throughout it. Proximity and zoning. So these are two things. So that's both near-based queries, including slot factors. Zoning is something that may be kind of specific to us. So we tend to define these kind of zones of a story. So in this example, it's kind of saying, basically within the top 75 words of a story, generally that's where sort of writers will put the most important elements of the story. So that's why people may sort of particularly want to query that area. We have phrase searches, we have wildcard searches, time-based ranges, and kind of a whole bunch of other filters that may go on top of that. So, as I was saying earlier, so that was a relatively simple example. They can get substantially longer. We do have limits on our queries, but they can be anything like sort of 20,000 characters in size. One of the reasons for that may be a finance sort of concept called a ticker list, which is kind of like a mailing list. So if you have sort of 10 people that you generally mail to, rather than keep writing them all the time, you create a shortcut, which is a mailing list of all your 10 friends or so. Organizations do this. Obviously, there's the FTSE 100, S&P 500. They're the sort of well-known ones. But also portfolio managers will also create sort of lists of equities that they're particularly interested in. For us, that's a problem because it means that's effectively a huge OR query, which, as I'm sure you're aware, is not particularly efficient. Sourcing, so as I said earlier, we've got data from probably 125,000 sources. Users can be privileged for any one or all of those sources, so they could be subscription-based. So that's a whole kind of custom privileging model, which is kind of bespoke for us at the moment. That may be something that we can look at contributing back. But at the moment, that's done as a post filter in the search system, and there's basically a bespoke solution in alerting. And then we have languages. So we've got data in 40-odd languages. Again, people could be kind of querying for any and all of those. So that was just kind of the basic problem. Now we come to, so what is an alert? Well, an alert, I guess, basically as kind of, I'm sure you're familiar with the Google Alerts kind of concept. You run a query, you run a search, and you say, okay, I'm interested in anything that would come into this search if I were to run it again. So that's fairly straightforward. Yes, we've got a fair number of those. We've got 1.5 million of those saved searches that people have created over the years. But we've also got what we call scrolling alerts. So most of the new searches within the organization are either time-based or relevance-based. Now, the time-based ones, obviously, as time generally moves forward, not involving Einstein at least, what happens is basically we run an initial search, and then users will expect that as new stories come in that would meet the same criteria, they basically scroll into the screen. So that means that pretty much every search that a user runs is also an alert. So instead of 1.5 million alerts a day, we've got about 5.5 million alerts a day. And obviously those can be very time dependent. When everybody logs on, when New York logs on in the morning, there's a massive spike. And I think we've seen anywhere up to 200 odd subscriptions a second coming into our alerting pipeline, which can be kind of interesting. We also have the same privileging problem that we have with search. We have a variety of different delivery options. Users can either get a message, that could be a real-time message or a digest type message. They can have pop-ups on their screen. There's kind of a variety of different delivery mechanisms they can use in-house. Those obviously were all existing. The migration that we've been doing has been away from a proprietary solution to this kind of open source one. So most of that pipeline already existed. Excuse me. And obviously, if you've got teams of guys, of traders, they may all have very similar alerts or the same alert, but some kind of little customizations that each user has. Brief digression. This is something that I just wanted to mention in passing. This isn't done via anything kind of Solr or Lucene based. But there is actually a need for something even faster than 100 milliseconds. What happens with kind of major economic announcements, so I guess kind of when the Fed and that kind of thing make their major releases, basically what happens is all the reporters literally get locked in a room. They all write their little stories. And then they basically sort of, at some point, all get released. And it is literally, a race to who can release this story first. What we have is a very custom solution for that. It tends to basically skip augmentation. There may literally just be a headline, no body text. But that lets us sort of basically generate something within probably 20 milliseconds or so. You could do the whole kind of body extraction, but then that maybe adds 50 milliseconds to it, and that's something that we're not really prepared, or our clients are not prepared to wait for. So that was, as I said, brief digression. That's not really what we're here to talk about. In terms of the alerting solution we needed to build here. So we started with basically a custom Solr component. That was literally something we probably put together in about a day. As you can imagine, that's basically a sort of brute force approach. So you've got a whole set of queries. You just have an API that you add. You let queries be added to this sort of giant map. And then when a document comes in, you just run a big iterator over that map and run all the queries over it. Well, that kind of works. But obviously, once you get into 1 million, 2 million, 3 million alerts, then that doesn't sort of scale particularly well. Yes, it does scale, but it's still a fairly naive approach. So as I said, we built it in a day, and within about 2 days worked out that wasn't really going to get us very far. So we then started looking at the Luwak library, which Alan Woodward and the rest of the Flash Search guys over in Cambridge had developed. So who's familiar with Luwak? Anyone here heard of it? Okay, not that many. Okay, so I'll kind of talk about that. Oops, jumped ahead. So what is Luwak? So Luwak basically is, it says, okay, this naive approach for alerting is fairly straightforward, but we think we can do better. So it's a Lucene-based library. So there's no kind of immediate Solr dependency. And it basically takes this process into a two sort of phase approach. So it has what it calls a pre-searcher. And basically the idea is, at some point, we're going to have to take a list of saved searches and run them against a document. But the idea is to try and trim out as many of those at the start as we can get away with. So any that we know there is no way they could possibly match, we can get rid of. So if we can trim that set down using a variety of different mechanisms, then obviously the iterator part we can do more efficiently just because we've got less searches to go over. It was dependent on a very large intervals patch. All right, yeah, that's probably best. It was dependent on a large patch of Lucene called intervals, aka Lucene 2878. Basically, in order to return the whole kind of highlighting, so as part of, you could just return whether this query matched, but for us specifically, if you've got kind of a keyword search, you need to know, okay, which bits of the query matched? Where exactly was that match? So in order to do that, there was this patch called intervals that was based on top of Lucene, and that was necessary for Luwak to work. We've actually basically paid or involved Alan to try and sort of give him time to get that contributed back into Lucene. And as of 5.3, that has now been contributed back. It's in trunk Lucene, and so you can build Luwak straight off of trunk, Lucene 5.3, 5.4, etc. So what does Luwak do? So as I said, its goal is kind of twofold. Basically, we're trying to trim out queries that we know can't possibly match the document. Now, there's a variety of different ways we can do that. But the first part is basically to try, for each particular query, to try and extract useful, in inverted commas, terms from that query. Now, so for a case in point, if you've got a conjunction query, so you've got an and, you've got maybe 5 terms anded together. Now, if you could find the least occurring of those 5 terms, then in effect, that's the most important one. Because if that one doesn't match your document, then there's no point in testing any of the others. So you can instantly say, well, if that's just a simple, if this term is there, then it's a potential match. If this term isn't there, then there's no point in even running that query at all. For disjunctions, then for all queries, yes, you still have to check all the terms, although I think you can still make use of term frequency to kind of play around with the order in which you check those. It has some other useful parts about sort of trying to make use of longer terms. Again, you're trying to sort of work with the term. You're trying to find basically the parts of the query that are kind of most distinct. So as I said, what it does is it builds this Lucene index, which is this useful data out of all of your queries. Then the second phase of that is to basically actually process the document. So you've got your document, you index it effectively as normal into an in-memory index. Now that could literally be memory, the Lucene memory index, although the latest versions of Luwak do support batches of documents, in which case it ends up using a RAM directory, because that's kind of just about as efficient for a couple of documents at least. And then what you get out of it is basically a list of matches. So it'll give you a list of subscriptions that would have returned this document if they'd been run as a search. Again, there's a couple of bits of information you can return with that. No, I've jumped ahead. You can either return just a simple Boolean, whether or not it matched. For us, we return basically highlight information, so that's sort of positional information on whereabouts exactly the match occurred. There are also some extensions that we're working on around scoring, so you can try and score particular alerts. So there's a bunch of different information that you can return. That's kind of Luwak in a nutshell. The next thing, so as I said, Luwak is just a library. At the end of the day, you have to do the integration to make it sort of integrate with the rest of your system. Baleen is something that we've kind of written in-house. It's a fairly straightforward Spring-based web app that just kind of wraps Luwak up with a couple of customizations on our side and just makes it accessible over an HTTP interface. You've got kind of the usual APIs, subscriptions, matching information, and then some kind of metrics and heartbeat stuff. It will plug into a Solr parser, a Solr query parser. So that's one extension that we've put into that. As I said, obviously the Luwak stuff itself was just assuming a Lucene queue parser, but we've added some functionality around Solr query parsers. We have to make use of, because we have obviously that external query language, which is our bespoke query language, we have to effectively do some validation on that before we get anywhere near Solr, so it doesn't make sense to actually write a Solr parser for that. We've made use of the XML parser, which was done in Solr 8.3.9. We finally managed to get that contributed back. We still kind of extend that on our side, but the core XML parser is now part of Solr. We use that because it basically lets us generate a query as a complete tree. So rather than a user-generated query, which is what we've already parsed in our front end, we've already turned that into basically a Lucene query tree. And that's what that XML format lets us create. We also have, so as I mentioned earlier, Luwak kind of needs to make use of term frequencies in order to make some of its decisions. Currently, we have some file-based. So basically, we have to take the term frequencies from our search index, copy them across to the alerting platform, and then we can make use of them there. There is a goal to make that more dynamic, so that will become something that we will either use within Solr, so we could have basically distributed IDF within Solr, and then we can also distribute that across to this Baleen platform as well. Lastly, we have some, so I'm sure you're kind of familiar with the commit within functionality within Solr itself. Obviously, as the subscription rates I was kind of mentioning earlier, if we were to literally commit with every subscription as and when it came in, we'd spend most of our time in I/O, even on SSDs. So we have basically a commit within equivalent for Luwak. So the idea of this is basically you can kind of batch up commits. We're still kind of working with Alan. We had something that kind of worked on an earlier version of Luwak on Luwak 1.1. But the interfaces of Luwak have changed quite a lot over the past couple of releases as it's kind of moved towards Lucene 5. So we need to kind of rework that slightly. But I was discussing that with Alan at Revolution last year, so we just need to get around to reporting that, and then we'll contribute that back to Luwak itself. In terms of the kind of observations that we found along the way, oops, excuse me. So yeah, there's been a lot of pull requests that we've been involved with Alan. So as I said, Luwak needs to be able to extract terms out of all types of queries. So there's a couple of term extractors we've had to send back. Filters was something that it didn't support particularly well to start with. We had the luxury of being able to tune our queries. So we ended up changing most of our filter queries into just alternate query types. Ironically, I think filters have now been deprecated in Lucene 5 anyway. So we seem to have kind of come full circle on that one. The index itself, so the index that that Luwak creates, obviously depending on its size, for us on each machine, it's still about 80 or 90 gig. You probably don't want to do that with a RAM directory because it'll just eat into your Java heap. So we ended up finding that an mmap directory on dev.shm was significantly better. We have enough RAM on those boxes to basically allow the SHM to be that big. An mmap directory kind of works much better at that kind of scale. There have been a couple of locking issues that we've found, again, just due to our kind of subscription rate and this whole kind of delayed commit stuff that I mentioned earlier. So Alan's been very good at kind of taking our suggestions on that front. Two last things on this. So parallelizing. So obviously, as I said, once you get to this second phase in Luwak, once you've got a list of potential matches, you've got to run them over all of your, you've got to run all those queries over your single document. Originally, that was done in a serial manner. We worked with Alan to create a parallel matcher for that. And there's also, as I said, some scoring. So the idea is being able to score your alert. So rather than just, yes, this matched, how well did it match, to give that alert a score. This could be an interesting one. This was a bug we started to see. This was actually a bug in Luwak that we found. So we had the problem we had was we noticed certain alerts started failing, but consistently across a particular language. Now for us, it was Korean. We thought, okay, maybe it's just some weird sort of tokenization issue in Korean. But we then dug a bit further, and language was actually a numeric field in our Solr schema. So that basically as that gets stored in the index, it's a packed integer as a bytes ref. Now that basically wasn't getting stored properly in the Lucene version, in Luwak's version of the index. Now it turned out that only got broken for certain language codes. So language code 9, which happened to be Korean, and 10 was broken. Then 11 and 12 seemed to work, and then 13 was broken. So we kind of scratched our heads for a while, thinking, okay, this is a bit bizarre. It actually turned out that because Luwak was originally designed for white space delimited text, when it was extracting values and putting them in the index, it was assuming that they were strings and it could concatenate them together with spaces and then run a white space tokenizer over them, which unfortunately meant that all our things like value 9, which if anyone can remember their ASCII tables is the tab character, and 10 and 13, which are carriage return and line feed, were nicely getting wiped out. So we identified that. We managed to find a valid test case for that. Alan's fixed that in the latest version of Luwak. We managed to work around it because we just haven't taken that port across. But that is fixed in the latest version. This was one that we actually introduced ourselves. We'd had some slightly over enthusiastic optimization. So we had we had queries where an alert would work in a particular dev environment, but as soon as we took exactly the same alert to production, it failed, and it never matched any stories. We couldn't work out why this was for a while. Basically what happened was in the pre-searcher, the term pre-searcher, there was an optimization which made an assumption that a particular term value would only occur once. So which could be sensible, because if you have a scenario where, I don't know, say you've got a query like oil, say it's like oil and Saudi Arabia, or oil and Iran, or oil and Iraq. It's not a particularly well-formed query, but it works. But you don't really want to extract the term oil 3 times, because that's just duplication. So that kind of deduping makes sense, but we also had the problem that something, maybe not oil, but maybe something like IBM, yes, it works as a company name, but it's also a keyword. So you may well have keyword searches for IBM. And we had a scenario where basically if there was a keyword query for IBM, then it was taking that, and it was basically then not adding in. If it saw then a content query or a topic-based query for IBM, it was ignoring that, saying, well, I've already seen IBM, so I know everything I need to know about IBM. So that kind of caused us a bit of a hassle, but we eventually managed to sort that one out. So that was a bug on our side. We decided not to contribute that particular optimization back, oddly enough. Next kind of steps. So that's kind of where we are at the moment. Next steps are Luwak's. Our pre-searcher is still probably relatively inefficient. So we have a lot of wildcard queries. We're still probably barely making 50% sort of efficiency, and we need to try and get that up in order to sort of basically make best use of the pre-searcher and to try and sort of reduce the overall latency that we can get out. So that's something we're working on. As I said earlier, the commit within thing we're still trying to get contributed back into Luwak trunk. On Baleen itself, so at the moment Baleen excuse me, is literally just a matching engine. So it's a fairly basic web app. There are obviously a lot of things we could do with that. We certainly need to make it more pluggable. The whole sort of query loading, as I said, the alert delivery pipeline is something that we already had. So we've basically just kind of kept our existing services for that. Baleen doesn't really know anything about those. Privileging is something that, again, we've kind of kept existing. So those could all be things that we could make pluggable within that. So then it would be up to sort of whoever was using it to add in whatever delivery options they wanted. We probably still need to make better integration into Solr. At the moment, as I said, this is a separate web application. The goal probably is to then integrate it back into Solr. It has some dependencies because we make use of the Solr parsers. But yeah, it's something that ideally we'd probably want as some kind of a custom component within the whole Solr pipeline. Query deduping, again, there's a bunch of stuff that we kind of do on the front end that ideally we could do within Baleen itself. The goal would then be to try and open source this as a complete alerting solution. The embedded JVM is something that may be kind of specific to us. So as I said, at the moment we have a front end that talks to this over HTTP. Whether or not that really makes sense for us, or whether it makes sense to just embed the whole thing within our front end, because we're always going to need our front end. But for other users, the HTTP interface or integrating to Solr may well be the best way forward. That, I think, is pretty much everything I had. Questions? The entity rent, at the moment that's an in-house. It's an in-house solution. I don't think it's anything library-based, so it's just an in-house solution at the moment.
It's not Stanford or OpenLP, nothing?
Not that I know of. It's not an area I particularly in my team are kind of aware of, but I think it's just an in-house solution.
And about training basically creating the models for entity recognition, that's also custom in-house?
I believe so, yes. But as I said, that kind of whole entity recognition and classification area is not something I'm sort of in my team particularly work on.
Thank you.
So Luwak is using Lucene while your search is using Solr. How do you make the queries work the same way on both, right? So Lucene, Solr has the tokenizers, analyzers
Yep.
on top of what Lucene offers.
So yeah, so there's that. So the part of Baleen basically has this. We've basically put a very sort of simplistic wrapper around, I think, a Solr core to be able to let certain query parsers work within within this framework. So certainly in terms of tokenizers and stuff, yes, we can make use of those. I think the Solr query parser itself does a load of stuff with the core, so it's going to depend on each query parser kind of has its own specific needs. Some of them will work, some of them won't. We did kind of enough, as I said, for our XML-based parser, but yeah, other parsers would probably need more work to integrate, depending sort of how much of Solr it needs.
And like you said, you were dealing with 40 languages, so
Yep.
that must have been a good amount of work, right?
We'd already had to do that on the search side anyway. So we've already got, as I said, we kind of already parse that outside. We do that in our front-end systems and then just generate effectively a Solr query, a Lucene query tree at that point. That's what the XML parser takes. It's an XML object, but it's basically a Lucene query tree by that point.
Ah, okay, that makes sense.
Nobody has any more questions. We can leave it there. There's more pizza outside, drinks, and thanks.
Thank you.
For,